So from a previous lesson, you know that we can relate a right triangle to sine and cosine and tangent. In particular, if our angle there is called theta, and this is a right angle, then we know that the sine of theta is the opposite side, which is y, over the radius, which is r. We know that the cosine of theta is the adjacent side, which is x, over the radius, which is r. And we know that the tangent of the angle is y over x, opposite over adjacent. Now, so far, I gave you the sides of the triangle, and you used that information to find sine, cosine, and tangent. What if we wanted to use the angle along with some of the sides to find missing sides? Well, that's a thing we can do. So imagine for just a minute that I don't know any of these. Then I need at least a little bit of information to help me out. Well, what if I know that this angle right here, theta, is 30 degrees? And I know that the hypotenuse right here, the radius of the circle, is 4 inches. Well, then that information should be enough for me to figure out the missing sides. Let's go after side y first. All right, now you take a look at what we know. I know the radius. I know the angle. I want to find y, and I want to use one of my trig functions. Well, if I look at all three of my trig functions, I find that sine of theta uses y over radius. Well, I know theta, so I can fill in that blank, and I know radius, so I can fill in that blank, and that only leaves y as my unknown. So now I'm going to fill in the blanks, and I have sine of 30 degrees is y, which I do not know, over the radius, which is 4 inches. Now, to finish solving this, I'm going to need to find out what the sine of 30 degrees is. And you can find that by looking on your unit circle, or you can find it by using your calculator. Let's go to the calculator right now. So I'm going over here to my calculator. And the first thing you want to do whenever you go to the calculator is press mode. The mode button is that button right there next to second. And go down here until you get to this one right here where it says radian or degree. Over here in this particular problem, my angle was given to me as 30 degrees, so I want to make sure that my mode is in degrees. What if the problem had been in radians? Then I would be pressing the down arrow right here, move my cursor over to that row, and then when the cursor is blinking on top of radians, I would hit enter, and that switches it over. But in this case, I don't want to be on radians, I want to be on degrees. So let me put the cursor back on degrees and hit enter. And now you see it's on degrees. Okay, once you've done that, you can hit second quit to go back to your home screen. And I need to know what the sine of 30 degrees is. So sine 30, enter, and I get 0.5. So now I can come back over here to this problem, and I can write in place of sine 30, I can write 1/2 or 0.5 equals y over 4 inches. And now if I multiply both sides by 4 inches, four inches here cancels out with 4 inches there. The 4 here cancels out with the 2. 2 becomes a 1, 4 becomes a 2. And I get 2 inches equals y. So now, this side y that I did not know before, now I know it is equal to 2 inches. Well, that's not very dark. Let's change colors. How about that? Y is equal to 2 inches. Now, I still need to find this side down here, because I want to try and find both sides. Now, you're probably saying, Mr. Dunn, wait a minute, you could just use the Pythagorean theorem from here on out. You're absolutely right, I could. But let's get a little practice using sine and cosine and tangent, because we're going to need those skills. So what if I wanted to use sine or cosine or tangent? Well, this time I'm looking for side X right there. What do I know? I know the radius and I know the angle. I also know Y, but let's see if I can figure out just using the information I was originally given, the radius and the angle. Well, let's see. That's X, that's the radius, and that's this angle. If I look at sine and cosine and tangent, I find that cosine of the angle is equal to X over the radius. And I know what the angle is, and I know what the radius is, so I can fill in 2 out of the 3 of the blanks. So now filling in the blanks, I have cosine of theta, cosine of, and my angle is 30 degrees, equals X, which I do not know, over the radius, which I know is 4 inches. Just like before, I need to find out what cosine of 30 is. So I'm going to go back over here to my calculator and type cosine 30, hit enter, and I get 0.866. So I now have, in place of cosine 30, 0.866. And there are a lot more digits there, but I'm just going to round off to 0.866 is equal to X over 4 inches. Just like we did last time, I now want to multiply both sides by 4 inches. Now over here on the right, 4 inches cancels out with 4 inches, leaving X by itself. Over here on the left, I need to multiply those. But I want to get the best answer I can, and the best answer I can get would be to take the previous answer with all of the digits, no rounding, and multiply that by 4. And I get 3.46. So our other side X right here is 3.46 inches long. X is 3.46 inches long. And so now I know the 2 sides I did not already know by using sine for one of them and cosine for the other. Let's do one more of these. So here is another right triangle. It's kind of funny looking, but there's the right angle. It's a right triangle. And this side right here is 12.5 meters. And this angle right here is 43 degrees. Now I can label this any way I want. So how about if I call this side X, I call this side Y, and always you want to call the hypotenuse R. Always, always, the side across from the right angle, the hypotenuse, always call that the radius. And then this 43 degrees right here, that is obviously my angle theta. And I want to find angle Y. Side Y, I mean, side Y. So I'm thinking about sine and cosine and tangent. Well, here's my angle. I know X, I want to know Y. And the trig function that uses the angle X and Y is tangent. So I have tangent of theta equals Y over X. Filling in the blanks, I have tangent of 43 degrees equals Y, which I do not know, over 12.5 meters. Now what is tangent of 43? I don't know what tangent of 43 is, but I know how to go to my calculator and find out. So going to my calculator, I'm going to check my mode again. I'm in degrees like I want to be. Tangent 43 gives me 0.9325 or 0.933. So I now have 0.933 is Y over 12.5 meters. Now what do I need to do to both sides to get Y by itself? I need to multiply by 12.5. So I'm going to multiply 12.5 meters and multiply over here 12.5 meters. Notice over here on the right, the 12.5s cancel. And now I need to multiply those two. But again, 9.33, that was a rounded off number. The number's not really 9.33, it's really 0.9325150861, and there probably some more numbers after that. So I'm going to take that number with no rounding, and that's what I'm going to multiply by 12.5 to get my answer, 11.656438. Now, what should I round that off to when I write down my final answer? Well, my answer's over here. 43 degrees has two significant figures. 12.5 has three significant figures. And remember, from science, you always go with the least significant figures. So this says I should go with two significant figures. And so 11.656 is going to round to 12 meters is our unknown side y. So now I can add that to my picture. My unknown side y here is 12 meters. What about the radius? Hey, Mr. Nunn, we know two legs of a right triangle. We could use the Pythagorean theorem. You're absolutely right. We certainly could. But I want to get some practice using sine and cosine and tangent. So let's try a different approach. So I'm going to take this side that I was given x and this angle that I was given theta, and I want to find the radius. So let's see. I know the angle. I know x. I'm looking at the radius. Which trig function uses x and the radius? That would be cosine. So my formula is cosine of theta equals x over radius. So filling in the blanks, cosine of 43 degrees, that's theta, equals x, which is 12.5 meters, divided by r, which I do not know. So what am I going to do next? I'm going to find cosine of 43 degrees. So going over to my calculator, cosine 43 degrees gives me that number, 0.731. So I have 0.731 equals 12.5 meters over r. Now I need to solve for r, so you notice I'm going to have to cross multiply and cross divide. R needs to multiply to the other side, and 0.731 needs to divide to the other side. So I get r is equal to 12.5 over 0.731. Now running back over here to my calculator, so I need 12.5 divided by, and again, I'm not going to estimate, I'm going to copy that number exactly and then hit enter, and I get that x is 17.09. Again, I only have two significant figures here, so I'm going to round, I'm sorry, I said x, I should have said r. R is 17.09. I'm going to round that to two significant figures. So my final answer here for the radius is 17 meters. R is 17 meters. And so now, using this angle and this side, I was able to find the other two